Okay, so we now know that if we have one logarithm of a very complicated expression, complicated because there's maybe a quotient or a product or powers appearing, we can untangle that and make it into a whole bunch of simpler expressions that are either added together or subtracted. Okay, fine. But what about the other direction? I mean, suppose you're on a desert island and you only have one log. One log, that's all you have, one log, and you've got to make it last. So the question is, how can you take a whole bunch of logs and compress them down into one? Okay, well, let's try to do that and take a look at some examples where the question is, take a whole bunch of logs, shrink it down to one expression that's equal to the original thing, but only one log. Look, Mom, only one log. No. Okay, here we go. Log base 10 of x plus 5 plus, ooh, I might run out of room here, 2 log base 10 of x. And there's a whole bunch of logs, and I want to write this in terms of just one log. So how do we do this? By the way, here's a little side note. And the side note is there's a shorthand. You know, base 10 in logarithms are used an awful lot in life. Oh, engineers use them, mathematicians use them, physicists use them. Boy, you name it, they use them. So a lot of times, what we just write is just a log with no base written. Sort of it's a naked log. If you see a naked log, you should understand that's log base 10. This is notation now. Notation. A naked log just means the invisible base must be 10. So in fact, I'll start using that now just to sort of illustrate that and also to save time. So you may say, hey, wait a minute. I have a sum of logs, and so that's going to be the log of a product. Well, that's a good thought, but the problem is there's a 2 in front of this. So it's not really a sum of logs. It's the sum of a log and 2 times the log. How can I get rid of that 2? Well, I can go backwards with that property that says this can be put up as a coefficient up there. So let me do that first. Remember, that's this property right here. Let me just flash this up on the screen here. It's this property here. But now I'm given a 2 log of something. I could write that as log of something squared. You see how I'm using this formula backwards? I can use it backwards right now with this. So this equals log base 10. Shoot, I wouldn't want to write base 10 anymore. Oh, no. Plus, but now I'm going to write log, no base 10, x squared. And what that means, by the way, is that's the log of x squared. Do you see how that 2 went up to here? I could bring it back down again. Watch. Whoop. Or I could bring it up. Whoop. Down. Whoop. Up. Whoop. They're both the same. So I'm going to write it this way, though, because now I've got a log of something plus a log of something. I can put them together since the bases are the same. The bases have to be the same, because remember in the formula, right here, it's log base b of a product equals log base b of x plus log base b of y. So if I've got the sum of logs, the bases have to match up. The bases have to match up in order for me to combine them. If I have a log base 3 of x and a log base 7 of x, I can't combine this. No, no, no. Bases have to match up. But happily, a 10 and a naked, that's 10. So in fact, the bases do match up. So I can write this happily as log, I'm not going to write anything, of x plus 5 times x squared. This is the exact same expression, but you'll notice that here I just have one log instead of the 2. And you can see how I went from here to here. I break this up as a sum and then pull the 2 out, and I get that. One log, one log. OK, let's try another one together. Let's try this one. So there's that one. Sorry, just wanted to do that superfluous sound effect. OK, 3 log base 4 of x. Now I have to write in that 4, since I want to tell you it's 4, not 10. 2 times log base 4 of z, or z if you're watching in Canada, or England, ooh la la, plus 2 times log base 4 of w, or w if you're watching in Canada. Well, what can you do here? Well, in one fell swoop, I can pick up all those coefficients and turn them into exponents just by picking them right out to there. And if I do that, using that property carefully, I see log of base 4 of x cubed minus log base 4 of z squared plus log base 4 of w squared. Now, how can I put together these other things? Well, I see a difference of logs. That means log of the quotient. So using the formula, I see log base 4 of x cubed minus z squared. Do you see how I went from log of the difference of logs to a log of a quotient? X cubed divided by subtracting log z squared. Use the formula. Now I add log base 4 of w squared. And what do I get as an answer? Well, now I see log of something plus log of something else. The bases are the same. So in fact, it's the log of the product. So I could write this now as 1 log, no waiting, okay, as log base 4 of the quantity x cubed over z squared times w squared. You see how I took this sum and then took the product of the terms. Let's say there, that times that. If I broke it up this way, log of a product is the sum of the logs. And you could write this if you want to make it look a little bit prettier. It's always nice to make your logs look as pretty as possible. This is called finished wood. He's unfinished. Oh, don't grimace. It's good. X cubed times w squared all over z squared. So there's a very compact way of writing that with just 1 log in this fashion. Before I had many logs. Okay, another little notational thing I want to tell you about really fast. Remember, if I write a naked log means log base 10. It turns out that log base e, that special number, 2.71, that actually is so important that we have a special notation of writing this. Now, I can't just do naked log, because naked log, of course, is log base 10. In fact, this is sometimes referred to as the natural log. Or if you read things backward, log natural. Maybe that's French, log naturel. Anyway, we have a shorthand for that by writing exactly that, ln of x, log natural. So ln of x is just a symbol, and it's a shorthand for saying log base e of x. We just can't say naked log, because that's log base 10. It's already been taken. So a new name, natural log, and that's what I said, natural log. Natural log, ln x. If you see, look on the calculator, you'll see ln x. That means log base e of x. Okay, now armed with that little notational thing, I can ask you the following. Let's simplify log, natural log, ln x minus natural log of y plus natural log of z. I think I will do this problem in one step. These all just mean log base e, log base e, log base e. All the bases are the same. And I see the difference of logs. That means that's the log of the quotient. Well, I'll do it in 2 steps. Okay, I'll do it in 2 steps. So that's this piece. But now I see a sum of logs, so that's actually log of a product. So I have x over y times z, which equals natural log of xz over y. So an expression with a lot of logs can be shrunk down, if you're only allowed to have 1 log in life, to natural log xz all over y. All right, try compactifying these logarithms into just 1 log.